Hi, welcome to you in my channel. Today I will discuss about the machine learning Coursera of assignment solutions. Here the assignment solutions it is in the 8 assignment solutions, 8 week and exercise will be 7. So it is the main program here. So let me open all the function and file here one by one. After that I will go through it. So I will strongly suggest to do this assignment first. Uh, Broadly learn about the theoretical part whatever Andrew is teaching the courses, so it is really the best. So all the knowledge to all the equations and the functions whatever he is mentioned in this video tutorials is needed in this assignment. And if you like my videos, please like, share and subscribe to my channels. It will makes me motivate. So let's consider directly to the main file. It is the main file, the exercise 7. So in this exercise 7 we will first do the principal component analysis and K-means clustering. So the first part is the K-mean clustering. So in the K-mean clustering we will do from here. So find the closest centroid. To find the closest centroid, what will happen, you should have to initialized some centroid, and it will initialize the centroid as the data points. Okay, so before that we need the data. So here they're importing the data. After that they're taking the centroid as c. K is equal to 3. I mean the number of centroid will be 3. I mean value of k is 3 means number of centroid is 3, and when the data is plotted it will be plotted in the x and y axis. So obviously k will have k is 3, then there will be 3 x axis values and y axis values. So they're assuming the x axis and y axis value will be like this. So it is the first initializations. After that we want to find closest centroid. There is a function, this find closest centroid, that function is incomplete. So I told already you need to complete this function. Here you need to complete this function. So this function takes the argument on the parameter of x, number of input and initial centroids. Let's check how it is complete. So find closest centroid, it is here. So the upper part is already complete, just you should have to write the code for this one. After this much code you should have to write in the code. Let's see, they're taking m number of example for I is equal to 1 to m, I mean number of input from to 1 to number of input, and distance I is equal to 0, and to 1 of k is the value of 3. So there is another inside one for loop, so the for loop will goes for up to 3 and keep the value of k is equal to 3. So what is this? It is actually find the distances. So I already they already told in the video description the distances will be calculated as 1 by m is equal to, actually it is 1 by m, I mean m for number of inputs, so I already taken the m as j. Okay, so summation number I is equal to 1 to m to x of x superscript I minus mu subscript c of I square. So it is the dat functions, it is the it is the equations whatever I told. This function, it is calculating the distances of the input values and the centroids. After that we are taking the indexes of the centroids, and we are taking it, and we are taking the minimum indices, and we are storing it as idx of I1. These values we are storing these functions. So this one is the complete one. So now go to the main function again. So in the main functions I'm printing the output that the closest centroid for 3 example, it will print the closest 3 centroid, and the told the 3 centroid will be respectively like this, 1 2 3. Okay, and the program is paused here. Now for next, compute the means. You need to compute the means. So first part is the initialization is done, so you need to the means. After that we will move the centroid. So in that case you should have to compute the means. So to compute the means, they're taking the another function is compute centroid. In the compute centroid, the mean in calculating with the parameter uses of x and idx. Idx is mean initialized centroids or initialized clusters with the cluster value of k is equal to 3. So let's go to the functions and let's see how it works. And you should have to write this function. I mean, you should have to complete this function. This function is incomplete. Complete centroids. So let's go to the compute centroids. It is in there. In the compute centroids, let's say you should have to write only this much code, that small of k is equal to 1 to k. I mean, for all the clusters, the centroid will be k, and for all the values k and all the values of for column, it will be the mean value of x and idx y is equal to x, and for all these values. So you need to write only this much code to complete this one. So this is the enough for that. So now come to the main functions again, main code again. In the main code, when you will compute the compute the centroids mean, then you will print the centroid here, and they told the centroid will be like this. Now the program is paused. If further continue, we will go to the Kmean clustering. So in the Kmean clusterings, now they are importing the same data again with the same cluster considered as 3, and the number of iterations they're considering as 10. So each of the iteration the cluster will be moved, and the cluster will go to the approximate, I mean, where the data density is the high to that points. So cluster will be moving phases, that one. So this is the main part. It is returns the outputs at centroid and its indices, where it will run the Kmeans algorithms, Kmeans functions. And this function will compute that things. I mean, to moving the centroid, actually to move the centroid, it takes the responsibility, and the centroid will be moved, and with the parameters of x initial centroid and maximum iteration, and it will true. So this functions is already completed. This Kmeans, okay, you no need to write or no need to override the function. This function is already completed. So just for a quick um, quick tour, let's see the function how it is working. Kmeans. So Kmeans is here. We can go through the function very deeply, one by one, line by line wise, and you can see whatever each line is representing about. So no need of the changes in this code, it is already completed. So I'm cutting this, will cut this functions. And come back to the main function again. After center movings, I mean the cluster center is moving to the proper directions. Now the program is paused, and for further runnings, K-mean clustering on pixel. So in this programs, what happens, they're taking the body image, and we want to K-means clustering algorithm we will take, and after that we'll compress it. I mean, we'll compress, and will reduce the dimensions. So for that case, they're taking the image of small barred image, and small barred image is the they have RGB image. So in the image, A is equal to number of values in the 3 dimensions. So each of the values they're dividing into 55, that to make the value within a certain range, to make it, or to make it in a certain range means the value when we divided A by 220 to 255, all the values will become 0 to 1, and from that image we taking the image size, how much is the size. After that we are reshaping the image. We are reshape the image means we're taking the image, and image size 1 and image size 2 and 3, it will take exactly into 3 matrices. It will return to you, where each of the column will represent one R, G, and will be indices. Indices represents in the matrix where the number of rows will be in. So for further classification, you can run these particular lines. Okay, so in that image, in the barred image, they're taking 16 cluster, and the iterations, it will be moved for 10 iterations, maximum iterations. After randomly distributed centroid, the to get the proper centroid of the cluster, the program will be run up to 10 times. So this is the another things that it will return the initial centroids, and it will calculate the k-means centroid functions, where it will take the parameters of x and k. So k-means centroid will calculate what, let's say k-means centroid will calculate the k-means centroid. This is give you the centroids values of that. So how we'll do that? So for that, this is not completed, you should have to write just a two-line code for that. That will first randomly distribute the centroid, and from that centroid you will take the centroid at random index from 1 to k, and for all those values we'll take these values. Okay, first we'll consider all the values as a random centroid, and from this random centroid you will take this values as the centroid of the cluster. Come back to main program again, and running the k-means algorithms. You are running the k-mean algorithm. What does the k-mean algorithm? I told already in the just 2 minutes before. The k-means algorithm, after initializations in the centroid point, k-means algorithms just reduce the moving phase of the clustering algorithms. When endurance suggests that in the k-means algorithm have two parts. One is cluster assignment step, and another one is moving centroid step. So actually k-means is doing the moving centroid part. So to move the centroid, for k is equal to 1 to k, where k is equal to the values is 16, I think. This means values, no sorry, k is equal to, sorry, k is equal to 16, and maximum number of iteration will tend with this argument or parameter values. This function will run and gives the new centroid of the permanent centroid and its indices values. After that, program is paused. Now it is the image comparisons, where in the image comparisons what happened, you'll run the k-means algorithms, and it is find the first closest centroid is finding the first. I told already this function about. And after that, what happened, x recovery part recovered the data of the centroid, so centroid will recovered. After that, from reshape, actually what happened, reshape is the receipt is if there is any matrix. Okay, so matrix mixed in a vectorized form we are using the reshape. So in the reshape, it will give you the return to the values of n into 3 matrix, and 3-dimensional. So it will be gives the x reshape values, and in the reshape values we are plotting the proper image and the proper image, and along with that, it's reshaped, I mean after allocating the centroid, after moving the centroid, and after doing these things, whatever the data we are getting, sorry, whatever the image we are getting from that image, I mean from the original element, we are plotting this thing in the second subplot. So it is the first part, and this first part is completed. Okay, first part is completed. So let's run the program and see. Yeah, program is running. Yeah, the program is running here. So up to now all the things all right, good. Now Kmeans algorithm is running. So in this dataset there is a visualized, you can visualize there is a 3 cluster will be there. So they considered at the first time k is equal to 3. Now run the program again. So then moving the centroid part is there. It is a moving centroid part, I mean it is a run km is just doing this thing. It will run up to 10 times for 10 iterations. Let's see, it is changing, and is the last changing. So it reached the maximum centroid positions. Now k-means is done, program is paused. Let's run this program for k-means iterations. So number of 10 iterations calculated the value, and it is the bird image comparisons, image picture. I think data is a mistake in the second subplot, that's why it's not printing. But don't worry, I will recover this thing. I will upload the code in my GitHub in the proper way. So this part is completed, first part is completed. So let's go to the assignment second part. When the first part is completed, now you should have to do the second part. Here is the second part. Here we will do the principal component analysis problems. In the principal component analysis, in the second part, Yeah, data is imported here. First we are plotting the data with the axis of like this, and axis shape will be square. Now the program is paused. For further we will press enter, we will go to the program. Now we'll come to the principal component analysis. In that principal component analysis, we are first will do the feature normalization, because principal component analysis, feature normalization is a very important part, and you should have to aware about that, and you should have to do this thing in the first before the running of the PCA. So x norm is equal to x normalizations, use the function, use the value particular value, and sigma is the particular value. Let's see how it works. Feature normalization, this is already completed, you no need to write, no need to modify this function. This function is already completed, feature normalizations. So let's see at least one time how it is work. So feature normalizations is the code here, only this much code, and they written these codes. Okay, so no need to rewrite the code again, and no modifications needed. So I'm going to the principal component analysis, that program again. Here we are running the PCA. We will running the PCA with the function of PCA. It will return to matrix. One is U and one is S. With PCB takes the parameter of X normalizations. So you should have to complete that code and to get the proper values of U and X. So let's go to the PCA and complete it. In the PCA, you should have to write only these two lines to complete this one, where sigma values we want, and in the equations also they told the sigma values will be 1 by m into x transpose into x. I mean, it is the values of x square. Okay, and 1 by m is equal to number of, for m number of inputs, and it will gives actually u s and v is equal to s v d sigma, where actually s dv is represent for single value decompositions. I'm repeating this thing again. Single value decompositions takes the parameter sigma, and it will gives, or it will returns the output as u, s and v, where u is the matrix of n into 1 and s will be the one diagonal matrix. It will be returned to u. So this s and u is very important for us. This that one we're using. So we're cutting these things again. This part is complete. So here u and s we want. So u and s, we are, when we got this thing, so we'll go further. For that we'll now plot a lines that will make a draw line here with the values of mu and other others, and let's see how it is work. Draw line, this is the simple code. This is already completed, you no need to write the code, or no need to modification in this code. So I already told this part is already completed. Okay, this is plotting one graph. So top eigenvectors you need to complete. So when you will get the u values and v values, we are printing here the u values of u11 and u121, and the values is expected to this. When we will get the things in very permanent, then you can understand that your program is working correctly. Dimension reductions. Dimension reduction is the very important thing in PCA. So when your dataset have the n dimensions, you can reduce it into m dimension, where m is less than n. Neither in a figure, if it is 3D plot, 3-dimensional, so you can make it 2-dimensional. 2D plot, you can make it 1-dimensional. Is the great important features in PCA for dimensional reductions. Here we have plot the things first time, dimensional reductions, x norm time x norms, and it will BO means it will take the blue color of 0 shape values, and with the axis of like this, and the axis will be square. Now if there is only one cluster, so z will be run, and z is the project data, and x norm to u and k, and project data is the functions. You should have to um, write the function for that. You need to complete that one. So project data is the function. See, the project data, it will be done for number of input and number of clusters, where x is equal to x transpose, and projections k is equal to x transpose onto u. This formula is already given in discussion. So it is mentioned as z, and they told the z value actually in the equations. The z value will be x transpose of u. Okay, this thing is already discussed in the sections. So this, you should have to write this code for that, this much. Okay, fine, I'm going forward. So we are printing the z1's values, and it will be like this, and x rec, it will be the recovery data from ZU and K. By using ZU K, you will get the recovery data. So recovery data is here. I think these functions is you need to complete. You need to complete these functions. You will write the code for this much, where this thing is the main part of this code, and this thing is already discussed in the theoretical section, that it is the actual formula of x approximations is equal to u reductions into z. Okay, I mean, to get back the feature value again, you should have to write this function, or sorry, write this equations, or write this code. It's the main important. So when you complete that one, so they're printing the x reductions values of one, x reduction values of two for first one second column. Now draw a line that will be connected to the project line to the original point. For that case, they're printing one um, plot, and the plot with the feature of this thing, where I is equal to 1 to size of x normalizations into 1, and draw lines with the help of draw line function. They are plotting this one. So after here, this much to complete in the main programs. Loading and visualization of phase data. There, what happened in the phase data? They are loading the data, and they are plot the data in the first time to see to visualize the data how it is. After that, they are reducing this dimensionality, and they're plotting after reducing the dimensionality, and from reduce the dimensionality, they are going back to the actual or original features, original image, how it will be look like this. So this function is used. I mean, from a particular data, they are reducing it, and they are revert back to the original. So for that case, they imported that dataset, and the display dataset is doing here. And in this display dataset, it is very complicated for me, display dataset, to understand. Let's see, display dataset is the great code here, how it is completed by each of the axis separations, each of the row separations for each of the axis, and so row they are sectioning, they are putting the particular image. It's quite complicated for me. So by the way, go forward for it. So you are running facial data here, and we'll want to get back the eigenfaces. So for that cases, you need to first feature normalizations. I told this is very important before running PCA or data dimensionality relations also. So they're running the feature normalizations. After that, they are applying the PCS there. From there, they're getting the values of UVX, UVS, and from there they're returning back to the value of U and S. This is very important. After that, they're displaying the data at here in these sections. After that, dimensional reductions of the face, it is the original face, now it is their dimensional they are reducing. For that case, they're considering the cluster as a k is equal to 100, and z is equal to project data. G is equal to project data. It will be returns the values of z. It will be returns the values of z, and z, I think z, before I told these things that z will come with and the equations. Yeah, Z will come with an equations, with the proper equations, so where the Z is the dimensional reductions. If the x is the actual point, so if the x is like belongs to r to the power n, so Z will be belongs to r to the power m, to where m is less than of n. So think about in that directions also. If Z's feature will be less than of x feature, I mean in the main features, if x is 2 dimension 3 dimension, Z will be 2 dimension to 1 dimensions. So always Z feature will be less than of x feature, not feature, exactly it is dimension. So visualization of face after PCA dimensionality reductions. After getting the dimensionality reductions for k equal to 100, it is the recovery data, and they're plotting this thing into different plots. In first plot they're plotting the original dataset of the phase, and they're plotting the recovery phase from the reduction reduction dimensionality of the phase. And this part is ungraded exercise. In the ungraded exercise, that is what happened. They will there is the dataset. So in the dataset you will visualize the dataset. After that, it is the 3D dataset. Actually in the 3D dataset you will make it in 2D dataset. I mean you will do the dimensionality reductions here. They're taking the body image, and from body image they give the all the values is 0 to 1 here. After that they're doing the same operations. After that, whatever these things, you can go and browse through it. This part is already completed. For the understanding purpose you will go through it, and you can understand it. So let me run the program. So it is the visualizations of the data. So yeah, it is the visualization of the data. So after that we will run PCA. We will run the PCA, and then the PCA will plot a data line on the data set. So now each of the dataset will calculate the distance from PC line. So see, it is the calculate that PC line, and here dot line is the distance, minimum distance from the PC line. And each of the dataset, if it belong to the PCA, so it will be colored as red color. So further discussions, it is the facial image representations, the actual or original image. Now in that image they are decompose it, I mean they are making the dimensionality reductions, and it is the dimensionality reductions. Yeah. Now dimensionality reduction is done. See, each of the faces now look like hazy color. Now they will revert to the again to the original phase from dimensionality reduction phase to the original phase, but it will not get the actual phases shiny or in the descriptions, but it will goes to very similar to that. In the meanwhile time, I want to suggest you or request you, please share, like, and especially subscribe my channel. That will gives me motivations to make this video about like this. If you have any queries or have any suggestions for the video to improve the video, or like sound quality or any other things, then you can mention in the video description. So now it is the visualization of the reduce the dimensional data. It will take just 5 to 6 seconds. Just wait for that. Yeah, so it is the original faces image, and this is the recovery faces image. So let's zoom it, then you can understand. If you zoom it, let's see what is happening. See, in that case, and in that case, if you zoom it, see, both are look like same, but both are not look like same. Sorry, both are not look like same. you can see here it is the original image and a recovery image, but there is a difference in the original image and recovery image. So let's check it and see original image and recovery image. This is not look like same, so this one is shiny rather than right hand side recovery faces. So when you recover the dimensionality reductions to the revert back to the original, so you will not get the same property as original. Okay, by the way, go runs and the Kmeans algorithm is running. Now it is the 3D data and there is the ungraded exercise, and this is already completed just for understanding. So it is the 3D data. Now they are doing that data compressions and they make the 3D data to 2D data. So comes the program and see the data is now in 2D dimensions in the 2D dimensions data, and I mean it is a dimensionality reduction data. So after here the program is completed, so let's submit the program, my program. So before that I should have to do one more thing, that submit. Yeah. So wait for server. So I will request you, please subscribe, like my videos, and share it. That gives me the motivation. I think some internet problem I have, that's why it's take too much time. So after here the main part of the program is completed. So feel free to comment, feel free to reach out through me with the email of Palashmondal, PALASHMONDAL 351 @gmail.com. I repeat it again, PALASHMONDAL 351 @gmail.com. You can reach